DuckDB is an open-source column-oriented relational database that was first released in 2019. It's designed to provide high performance on complex queries against large databases and focuses on online analytical processing workloads. Hannes Mühleisen is the co-creator of DuckDB and is the CEO and co-founder of DuckDB Labs. He joins the show to talk about drawing inspiration from SQLite, why DuckDB was written in C++, the novel data processing scenarios it enables, and more. This episode is hosted by Lee Atchison. Lee Atchison is a software architect, author, and thought leader on cloud computing and application modernization. His best-selling book, Architecting for Scale, is an essential resource for technical teams looking to maintain high availability and manage risk in their cloud environments. Lee is the host of his podcast, Modern Digital Business, produced for people looking to build and grow their digital business. Listen at mdb.fm. Follow Lee at softwarearchitectureinsights.com and see all his content at leeatchison.com.
Hannes, welcome to Software Engineering Daily.
Thanks for having me, Lee.
Great. So we're talking about DuckDB today. And after reading a little bit about DuckDB, I'll have to be completely honest, I had not heard of DuckDB before I started preparing for this episode, but it sounds actually quite interesting. But my first thoughts were, it sounds kind of like SQLite on steroids. Now, you probably cringe when I say that, but what do you think about that comparison? And what would you say to people who make that comparison?
I think that's an actual pretty good comparison. In fact, we took a bunch of inspiration from SQLite when we started making DuckDB in the first place. So one of the things that we really loved about SQLite, there's many, but the first thing that we really loved about SQLite was its ease of use. So maybe if you have ever used SQLite, you know this, but there's no server to manage.
Right.
The database is just a library. It's a piece of code you glue to your application. And then the database file itself is just a file. And you can, instantiate the library, talk to the file, run queries, do table stuff. It's all fine. And I think it's really impressive how easy to use SQLite is. And that's one of the inspirations that actually we took to heart when building DuckDB, is that it should be the look, like the feeling, sort of the feeling should be kind of similar in the sense of like simplicity of use. Just, being able to just use a database as a library, it runs in the same process. That's really, really interesting because it's both simplifies handling and has a bunch of really great advantages in terms of performance. And then the steroids part, I'm not offended by the concept on steroids. We often call DuckDB the SQLite for analytics ourselves. So there's maybe something to understand here, that there's this difference between the transactional workloads that SQLite was built on, which is like, changing rows, updating rows, inserting rows, deleting rows, changing individual values, and the analytical workloads that DuckDB was built for, that are more like, I'm going to run a query on like 1 million rows or 1 billion rows, and I'm going to join 2 10 billion row tables together. And so that's more the analytical use case. And SQLite is not designed for it. It's not built for it. Its engine is not designed for it, but DuckDB's engine is. So we took some of the inspiration from the architecture, but we basically swapped the engine to an analytical engine. And in general, it's a complete, rewrite. That's not a rewrite. It's a complete sort of separate from scratch implementation. We did borrow their shell, however. So if you use the DuckDB command line interface, it's actually a patched version of the SQLite shell.
Oh, cool. It'll look very familiar to people actually using it. Is there a API compatibility with it? I know, obviously, from an SQL standpoint, that we can talk about the details there, but the in-process API itself, is that compatible?
So yes and no. Well, best answer. So we do have something called the SQLite API wrapper, which makes the DuckDB API look exactly and behave exactly like the SQLite API. And in fact, that's what we're using in the shell. So the shell is actually using the same sort of API calls it normally uses to call into SQLite to talk to DuckDB. And there's like some layers of software that make that happen. So we actually have a compatibility layer. So if your application runs on SQLite, chances are you can just swap that out with DuckDB without too much hassle if you're using the C API. But DuckDB itself has two main APIs. There's a C API, which is different from the SQLite API. And that has to do, why make a new API if there's one that people already use and like? No, that there's a reason for it. So because DuckDB works with analytical data sets, we use a columnar data representation. And that means that our client API also needs to be columnar, because one of the cardinal sins people do with data systems is they have a columnar system and then they slap a old school row-wise API on top, like the Postgres API and protocol, for example. And then you kind of lose a lot of the advantages when going in and out of that engine because you have to convert. So for that reason, we actually redesigned an API that was used columnar sort of design to access data that comes out of the thing and to put data in. And this is why we have our own API that's separate, different from the SQLite API. People that use SQLite C API will probably recognize a bunch of things though, because it looks a bit similar. But DuckDB itself is written in C++. So the C API is also another wrapper around the internal C++ APIs that you can also use to talk to DuckDB. And so that's the main API that people program again, although we are trying to move a bit more to the C API at the moment.
So built in C++ versus C, and SQLite was built in C. Why C++?
Database systems are old school in a way, right? Like if you think about things like SQLite indeed, or Postgres or MySQL, or pretty much all of them, they're all written in C. And that has to do with, I think, two things. That, first of all, when many systems were created, C++ simply did not exist. Or C++ for a long time had a bunch, like a bad rep, if you want.
Bad rep, yeah.
For some time, there were some issues with like performance of exceptions and things like that. And so data systems people being somewhat traditional and conservative, I think it's fair to say, went for the old school C. And I've spent a lot of time in my career writing data systems in C, or working on data systems that were written in C. And C99, great stuff. But when we started DuckDB in 2018, sort of the C++ had sort of been around for long enough that, it was actually zero regret abstraction where you could use things like exceptions and smart pointers and things like that without fearing for horrible performance regressions. Still, you have to be careful. Like, all this wonderful inheritance that C++ gives you is something that we cannot use the hot path of our data system at all, because there are all these virtual function calls, which is basically not work. So it's very tempting to write a abstract sort of database system. It has to be like polymorphic on the types, and there's different data types, and you have to do different things depending on which type. Sounds wonderful. Doesn't work in practice because of the overhead of virtual function pointers. So you do end up writing C++ that looks a lot like C in some way, but we are very, very happy with C++. We use like templates that make it very easy for us to generate code on compilation, which means that we can expand code into simpler code that then the compiler can efficiently generate machine code for these kind of things. So I think C++ kind of was a great middle ground between sort of the new world and the old world at the time in 2018, that we could kind of avoid some of the horribleness of C with regards to, error handling, memory management, the stuff, and not pay the performance penalty or the portability penalty of some of the more modern languages, right?
Yeah, I did my early career, I did mostly with C++, in the 90s
right.
and the early 2000s, I did a lot of C++. And back then you're right, it was starting to get a bad rap back in those days. And before some very specific, what I consider more corner case, but there were some very specific use cases that just didn't have the performance that you wanted it to have. But for the most part, it performed just as well as C, but it gave you some additional features like better memory management was one of the things I remember was one of the main things that I really loved about it, is not having the ability to build something that could be, memory leak free, or at least as close to it as possible without having to go through a lot of gyrations and a lot of hoops was one of the things I really liked about C++.
Yeah, we also really like that. Like we make heavy use of smart pointers in DuckDB. And as a result, memory leaks have not really been an issue. They pop up every now and then, usually in client APIs that have to talk to some other language ecosystem that then does its own memory management. Then things go wrong. But inside DuckDB itself, it's quite rare because, we can use smart pointers. The structures will clean the memory. Generally works well. You can have fairly complex data structures that just clean up after themselves. It's great. It's something that the SeaWorld still doesn't really have. SeaWorld sounds like SeaWorld, right? But the SeaWorld still doesn't have, no relation. SeaWorld doesn't have, and it makes it, you spend so much more time. I think from my perspective, it's a bit more like, okay, productivity of developers is higher in C++ because there's a bunch of stuff that you don't have to deal with. Still, C++ isn't the most modern language out there. There's, of course, newer ones like Go and Rust and all that stuff that try to fix some more things. But for us as a sort of low-level systems people, which I think we are, it's a good compromise. And we are actually also conservative in C++. Like DuckDB uses C++ 11, and you would say, why on earth are you on a 13-year-old version of C++ with your top-notch sort of data system? There's a very simple reason to it. We run on a bunch of platforms where GCC 4 point something is the newest compiler available, and that can only do C++ 11 reliably. So we actually made a conscious decision to be on the slightly older version that, has most of the nice things, but not the crazy nice things, just because we maximize compatibility and just sort of portability of the system as opposed to, the latest and greatest in the languages. Yeah, it's also an advantage to sort of simplifying a bit, or just to stay on slightly simpler technology on purpose, is that the code becomes way more accessible, right? Like if you're doing crazy meta-programming hacks in templates, it will be much harder for people to just jump into your code base and, maybe contribute or fix a bug or track down a bug, things like that, as opposed to, it's C++ 11, it's well understood, the tools like it, the debuggers like it, it all works really well.
There's something to be said for following simple guidelines that work well if you want to, especially if you're for an open source project like this, which we're going to get into in a little bit, the open source philosophy behind it. But let's stay with the SQLite comparison for a little bit here. So when you look at the use cases for SQLite, there's really two rather extreme independent use cases. One of them is simple startup of development environments. You can start something and use it, and it's easy to use and it just works. And as a development tool, it's good enough. And you can do a lot of really neat things with it. But the second use case is in production systems for small footprint embedded software applications. It's on-device applications or in-field devices and database usage in those cases. Those are really the two main use cases for SQLite. What is the main use cases for DuckDB and how does it compare there?
Yeah, I think that's an excellent question. I would say there's maybe three use cases as opposed to the two that you just mentioned for SQLite. I think we shared the aspect of people using it as a prototyping environment because, I don't know, Snowflake is expensive and you might as well run your queries locally on DuckDB to sort of iron out most of the problems. I mean, why not? People do that a lot. But then there's two more. And one of them is we don't really have this kind of tiny device thing because DuckDB, realistically, you need a couple of gigabytes of RAM to really take advantage of it. I mean, it can run on 500 megabytes or something, but it's really pushing it. SQLite can even run on statically allocated RAM. It can run anywhere. We can run on many things. People run DuckDB on phones, on watches and these kind of things, but these are pretty powerful computers at this point. I think the second use case is to do data analysis on like your local machine or like your Jupyter notebook that you run on a cloud device, whatever. It's this local data analysis aspect. So basically when we started DuckDB, we kind of built it for this case where we said people are doing a lot of stuff locally. In fact, many data sets do fit on single machines now. Let's give people a tool, a local data system that you can run, instead of spinning yet another Spark cluster. You can just, for many problems, you can just run a local instance of DuckDB on your machine, on your laptop. They're pretty fast. They can go pretty far in terms of data set sizes. And people use it a lot for that. I would say is a very big use case. It's just like people writing Python scripts, people writing R scripts, people writing their own thing in Go or whatever, using DuckDB on a local device to just crunch through some data, to read a CSV file, to convert it to a Parquet file, to read a Parquet file, to write, run an aggregation, run a big join, these kind of things. So a bit ad hoc, I would call this, right? It's ad hoc analysis. And the third one is also, that's one that kind of surprises, was that DuckDB, because it's so small and nimble and you don't need to manage a lot of state and anything like that, people also use it a lot in sort of enterprise data pipelines. So when you are running like some sort of weird long data pipeline, the one thing you don't want to do is to run a cluster next to it that runs something else, and then your pipeline servers have to call into the cluster. You get this load balancing issue, and it's all not very pretty. You kind of would rather put the data processing, the reshaping part, cleaning part, quality assessment, all that stuff into the pipeline itself. And DuckDB allows you to do that, right? Like, because we take a couple of milliseconds to spin up a database instance from scratch. Okay. You can run arbitrary queries with a state-of-the-art query engine. We haven't talked about that, but we can talk about that. It's a state-of-the-art query execution engine. And then you can, hand the data off to the next step. And that's a use case that surprised us a bit, how popular it was for that. And that's, I think, the third sort of big use case of DuckDB, where, it becomes a component. And people even run DuckDB on things like lambdas, right? Like that's a use case because you have a lambda. Okay, that's fine. You wouldn't start Postgres in your lambda. That makes zero sense. Postgres to initialize takes, 5 seconds. This is way too long for a lambda, but a couple of milliseconds to spin up DuckDB, fine. And one thing that people sometimes forget is that DuckDB can run on sort of anything. Like it's almost like one of these tank engines that can take any kind of fuel. We don't have to ingest data into our own storage from it before we can run queries. DuckDB can run on CSV files, it can run on Parquet files, it can run on arrow structures, it can run on God knows what. It's pretty versatile in that sense, and you don't have to actually ingest data, which means that if your data pipeline happens to produce a Parquet file, and you need to filter out these 3 annoying rows, it's like a one-liner in DuckDB, and people use that en masse to just plop that in and use it as a component, and that's really cool to see. We're kind of surprised by that.
So you ingest a Parquet file,
you don't have to ingest it. You just run the query on top directly.
Really? So you actually aren't. So I know one of the benefits you touted was the ability to read and write multiple file formats. I assume that was an ingestion and export process. It actually runs natively on top of those file formats.
That's right. So our query processing engine is built with an abstraction on the data source. So we have our own storage format. It's a great storage format. It's the best storage format. But if you have data somewhere else in, let's say, Parquet files, also a pretty good format, or CSV files, not such a great format, but still very much used, right?
Yeah.
You don't have to actually ingest. So you basically can point DuckDB to those files. They can also be on S3. It doesn't really matter where they are, but they can be local. They can be S3. You point them to those files and say, I want to run this query. And the engine DuckDB will actually directly execute the query on the file without ever ingesting. So it will do clever things like, on a Parquet file, for example, do clever things like, if you're not using a column in your query, it will never read these bytes from disk because it doesn't have to. It doesn't, from the structure of the file, it knows where the interesting things are. It will use statistics to prune, entire subtrees of the query because it knows that this file has no values that can fit this part of the query, so we might as well not do that. It's very clever. So our own storage format, the DuckDB file format, doesn't have a name. It's just the DuckDB file format. Our own storage format is slightly better here and there because we have slightly better statistics. We have, but in general, you can run DuckDB on almost anything. Like it works really well on things like Parquet and Arrow. It also works really great on CSV files, although there are optimization opportunities are a bit more limited because due to the nature of the file format, right? But I think we have the world's best CSV reader at this point because we really care about you being able to read data without ingesting.
This is really cool because one of the things I do a lot is I have applications that import from CSV files and having to deal with all the different file formats and all the different structures and stuff. It's kind of a pain to do in an application. But I imagine that, so with DuckDB, I could just read the file with whatever structure it has and then interpret the fields and do the magic work I need to do from within an SQL database instead of the CSV or some sort of CSV library that's trying to read it in.
Yeah, that's absolutely true. And you can point the engine to the CSV file. As I said, I think we have the world's best CSV reader. And there's actually a reason for it. This is not just because we deeply love CSVs, we don't.
Nobody deeply loves CSVs, but that's okay.
There might be some weirdos out there, who knows?
They're very useful in important places.
It's true. People have a love-hate relationship with them. I think that summarizes it fairly. But we have the world's best CSV reader because it's the first thing you do with your data system. And if that doesn't work, you're immediately frustrated. And so we realized, hang on, we got the installation covered. That's pretty easy because we have this whole SQLite style sort of, deployment. Let's deal with the second thing people do, which is this ingestion part, right? And not for copying into the file format, but also just for running queries on. And if that is a gigantic pain, then you're already frustrated. It certainly has happened to me like 20 times. I start trying to a new system. I have some files lying around. I want to ingest them. And it's like, 6 hours of screaming before that works. And so, which is why we heavily invested, actually, one of our guys Pedro, he's been working on that for a long time now. And I think he's done really an awesome job in getting a great CSV reader together. So it's also fast. Have I mentioned this?
I've already, in my mind, just even some of the things I'm doing for reading CSV files, I see huge advantages of being able to use it. So is that overkill to use you to read CSV files and then do manipulation through SQL? Is that overkill?
No, I wouldn't say so. I think that's perfect. I think there's like very few things that you can do with DuckDB that are overkill, right? Because it is so nimble, right? We are like,
small, yeah.
The binary is like a 20 megabyte thing. You can just install it from pip, or you can download the CLI or whatever, and it's up to you. But there is not like, if you're running a query that does like a single filter on a CSV file, I think it's already a much better user experience than anything else that's out there, right? Like, you're going to use grep for that? Sure, right? Like, that's not going to be fun. We see that a lot, that people just use like these very trivial queries, like, from this file, do this minor transformation and write down this other file. And our engine is perfectly happy with that. And we're happy with that. And it will be parallelized, which is otherwise also a gigantic pain to organize, right? Like, it will be automatically parallelized. It will be using highly efficient primitives from our execution engine. It will just be fully streaming. So that means it doesn't actually have to materialize any of that in memory. It will just go through it in a streaming fashion. So that's really, I don't think there's a use case too small. And I think that's also what sets DuckDB apart from like the competition, if you want. Like, there's all these big iron systems out there, but as you intuitively said, is there a use case for which it would be overkill? And there is like the standard thing is like, if you wanted to just read something from a CSV file, setting up Postgres, if the Postgres CSV parser were any good, which it isn't, would be massive overkill to set up Postgres just to read a CSV file. But it's not overkill at all, in my opinion. Obviously, I'm biased, but in my opinion, it's perfectly reasonable to just run a single query and only ever do that, and do that all day long. And why not, right?
The startup time is so short. Who cares, right?
Like, there's also nothing to like really do, right? What does initializing database mean? We parse our configuration. I think that was pretty much it, right? Like, it's
you don't have to read the file in to at initialization time. Yeah.
And we will also have, if you like, we will be lazily looking up metadata, these kind of things. Like, it will not do anything without it having to do it. I think it's an interesting sort of philosophical sort of difference. There's this company called Tailscale. I don't know if you've heard of them.
Yeah, I've heard of them.
And did you know that the name was a joke, actually? Because like, that's the lore I heard. The company was started by Google people, and inside Google, so I'm told, I've never worked for Google, they were making like these jokes about the tail scale problems as like the tail scale that's like the small problems with the long tail that we shouldn't be talking about because we're Google and we only care about like the
big part,
the beginning of the tail, the beginning of the I don't know, the whatever called, the high bits of the distribution,
high use, yeah.
Yeah. And then this company Tailscale was founded to be like, hang on, if we fix the problems of the people that in this long tail, this is also worth something, and they will probably give us loads of money. And it's true. And with DuckDB, it's kind of the same thing. We set out to solve the data problems for the 99% of us, because it's also in my world of, I come from academia where it's like you write the papers, who has the biggest data or something like that, right? It's so common to sort of solve the problems of the 1%ers. I know this is a bit of a war cry, has been a bit, but the point is, people love solving the problems of the 1%ers. People love solving Google's data problems in like their research, in their work and systems, because if it doesn't scale, it's useless. But we completely forget that 99% of data problems doesn't actually need any of that. And we have just made the life of people that have these problems so much harder, because our systems only work if you run them on 100 nodes, or I don't know what the minimum Spark cluster size these days is, but it's big, right? And so, but just by focusing on this, on the tail scale, if you want, I think we can provide a lot of sort of happiness. And, I love data systems, so I think they should be fun to use and make people happy, and not make people sort of frustrated, which is, I think, the state of the things of our...
Makes a lot of sense. Now, a lot of this you can do too, as far as, like the streaming of the incoming data versus storing in memory, et cetera, because you're focused on the analytics side. So you're doing a lot of select calls, right? And analytic select calls. But I imagine things like inserts and updates then become problematic, or at least slower. For instance, how do you insert into a CSV in a performant way? I'm assuming you can do those things, but I imagine it's less performant in those cases. Is that a fair statement?
SSC. So we can't actually insert into a CSV file because what I mentioned we can run on data formats is we can read them in a select query. We can't necessarily run transactions on them, right? Like this is a different problem. So we can read from them, we can write into other files, and some formats, as I said, for example, Parquet files, they don't really like being changed. Like it's very difficult to append at all to a Parquet file. It can be done, and we have some ideas, but it's not trivial.
And a Parquet file in an S3 bucket is even harder to do.
That's like, how do you do that, right? You have to read the whole thing, then rewrite it. It's not fun. But yeah, it's not a fun thing. And in order to update, we have our own file format that I mentioned before, the DuckDB file format. So if you want to do changes to your data, then they need to be in the DuckDB file format, or there's another cool feature. Since a couple of months or for a year or so, we've now had connectors to other data systems. Like you can, for example, you can attach a Postgres database or a MySQL database or a SQLite database to DuckDB. And then we can sort of treat them as our storage. So, and there's some really cool aspects of this. Like, for example, we can run queries on SQLite files faster than SQLite itself. And why is that? Because we can parallelize queries and SQLites can't. And our data access is as fast as SQLite's because we can just use their reading code on their data files. And yeah, so it's actually a great idea. And we can also run, and there we can run transactions. But to come back to transactions, it's actually an interesting question. What do updates actually mean for analytical data systems, right? And we thought about that quite a bit. Because you have, from the sort of your database undergrad course, you remember that there was this thing with the bank and the bank needed to send money and that was a transaction and there was 2 updates and yada, yada, yada. But if you think about what does this mean for analytical systems, do we really have these kind of queries analytics? And the answer is no, we don't have that. What we have is we have like interesting queries like, hey, read this 2 terabyte file into a table. Bam, that's a transaction update. But now this is really annoying because now you have to read 2 terabytes into a table. Okay, I'm exaggerating that way, but just, it could be. Actually, it happens. So we have done that. Other people have done that. That's okay. So now you're reading 2 terabytes into a table. That's a transaction that you have to be able to abort and roll back again. But how do you roll back a 2 terabyte transaction, right? It's not obvious. And it's actually created kind of a sort of collection of interesting problems to work on is how do you actually deal with sort of transactionality and in the presence of these crazy updates. Another aspect, okay, so we had the volume. So you have to be able to abort an ingestion of 2 terabytes and basically roll back as if nothing happened. Fun stuff. Another interesting aspect is like, it's very common in analytics to kind of add a column to a table that's like computed somehow from the other columns, right? Like you run some expression, it cleans up something, creates a new column. Right, now that means that we change every single row in that table because we just added a column. In traditional systems, this means a full rewrite of the table because Postgres can't deal with that. Postgres cannot, in its storage format, cannot deal with adding a column to an existing table because it's a row format. There's no space behind the row to put anything, so rewrite, right? Not great if the table is, again, 2 terabytes tall. So we have actually designed, I think, one of the first multi-version concurrency control schemes for SQL systems that are specifically tailored to bulk columnary updates, right? So if your changes are in somehow more columnar than row-based, and they tend to be in analytical systems, and if your updates tend to be more bulky than not, like you're adding 1,000 rows at a time, not one, then our system will outperform anything else out there. And it's still transactional, which is really cool. Like we still, like many data systems out there don't have that. They kind of traded away transactionality for some idea of performance, but we have managed to get all that done in such a way that if anything goes wrong, we can go back to the status quo ante without too much trouble. And that's I think pretty unique that you can do that.
Right. You talked at the very beginning about columnar access being more important, and that's really the reason why is because of these sorts of transactions. And okay, that's cool. That's cool.
Yeah.
And now that's of course with the native file format. If you're using
that's with the native file format. Yeah, that is the only one that we know of that is designed for these kind of things, right? Like this. Yeah.
Cool. But yet you can still import from, let's say, CSV file into your data file format and then export back out again. You can do that.
You can also run a select on a CSV file, no problem, right?
Yeah, right.
Just if you like, what does it mean? You're deleting a column from a CSV file. It probably means rewriting the file, right?
Right.
So that we can also do. Like that's not an issue. But that means that you read the whole thing, you change it, you write it back out. Like
right. Yeah, it's not
can also be done.
Not as performant, but it is possible to do. And it's
yeah, exactly. I mean, I don't think there's a performant way of deleting a column from a CSV file at all.
No.
Like if you think about it, how do you do that? Like the operating system, like the block APIs will not allow you to do that in any way, shape, or form. So I'm not a wizard. It's like I cannot do magic with operating systems.
And if you're dealing with a CSV file that's so large that the performance of rewriting it becomes a problem, you should be using another format anyway. But that's a different podcast episode right there, I think, to have that conversation.
I've seen things.
I have too. But should doesn't mean don't do, but yeah, definitely. So let's talk a little bit about you and the start of DuckDB.
Right.
Why did you build this?
Well, so I had a pet duck, and I thought, I'll have this pet duck, and I better build a database anyways, in seriousness. So DuckDB was built because I was doing research at the Dutch National Research Lab for Mathematics and Computer Science here in Amsterdam, together with Mark Rasfeld, who is the co-creator and also co-founder of DuckDB, who was then my PhD student. So we built DuckDB because we saw this need for what I mentioned earlier, for the tail scale, for solving the data problems for the 99%. We saw that there was this massive sort of lack of interest in single node processing, like focusing on performance on single node was a massive lack of sort of interest and also a lack of tooling. And it was pretty bleak. And the result was that people were just building their own data systems left and right. And we thought, hang on, we know a lot about data systems, but why don't these people use data systems? And it turned out because of the various issues in sort of ergonomics and just ease of use and these kind of things, that people were just ignoring them. And we thought, maybe they're ignoring us for the wrong reasons, Maybe they're ignoring us for the wrong reasons. That's a good way of putting it. So we set out and we thought about what does a data system, an analytical data system have to look like, in the long ago of 2018, that would actually be useful to the data scientist. And so that's how sort of the first version of DuckDB came around, is we started engaging with the community of data scientists. We still talk a lot with data scientists on what would work for them. And we did a bunch of prototypes and things looked promising. So we sat down and we started writing a database from scratch, which is, I'm not sure if you have sort of heard this, but this is a monumentous undertaking. Like, I'm one of these people that kind of leaps and then starts looking. It's probably good that it's like this because I would have never done it otherwise. Like, I have to admit, I have underestimated the effort to make a database management system greatly. And it's good because it's good. Otherwise, I would have never started it. I mean, now we are 6 years down the road and almost closed, actually, within a couple of months. And we are just getting ready to release our DuckDB 1.0 in the next couple of, weeks, months. We'll see. So that's kind of how long it took from us, starting building something from scratch, just Mark and me. Later joined by more people. Now we're about 20 people working, most of the time on DuckDB. But that's how long it took from nothing to something where we're like happy enough with to call it a 1.0. And that has to do, I think, with just because database systems have been around for so long, there's a lot of expectations. There's some very reasonable ones, like you shouldn't crash, you shouldn't lose my data. That's very reasonable. And then there's also just this incredible width of SQL. Like, I'm still finding out things about SQL I've never heard about. It's like nothing teaches you SQL as much as writing your own data system, because you have to write the engine that interprets other people's crazy SQL queries, right? And we learned things that we never knew existed. Like, for example, the other day, have you ever heard of union all?
I've heard of it. I'm not sure I could use it.
Okay, so in SQL, you have union and union all, okay? So you can take two queries, you union them together, you kind of glue the rows together from these two queries. Sounds pretty benign, right?
And then there's union. What union all is. So union versus union all?
Yes. A union actually has set semantics, so it removes duplicates from the result, and union all doesn't. Union all has bag semantics and doesn't do that. That's pretty well known. Okay? If you're writing SQL queries, you know that difference. I knew that difference. SQL also has something called intersect. I thought, okay, that's set sort of theoretic intersection. Sounds legit. And then, like a couple of months ago, somebody came to me and said, like, hey, did you know that there's also intersect all in the standard? And I'm like, what does this even mean? What does bag semantics mean on intersect? So it actually exists and we had to implement it, and now DuckDB supports it. But we learned so much about sort of the craziness, and maybe not aware of this, but SQL is actually a Turing complete language. So there is something called recursive CTEs, recursive common table expressions. And if you implement them correctly, you have a Turing-complete language. So we accidentally have built this execution engine for a Turing-complete language, which is terrifying, right? So come back to my earlier point, like there's just so much that you have to do. You have to get right. You have to get the transactions right because people expect transactions, rightly so, in my opinion. You have to get this crazy language under control. SQL, which is gigantic and has things that you've never heard of, and you have to implement them, which is much harder than to write them. Like, it's so much harder to get something right in all circumstances than to kind of use it, right? You're the person that has to think of all the eventualities. What if this isn't there? What if this isn't there? What if this happens? What happens? So that took quite a long time. And there's also just aspects that nobody thinks about so much. It's like parallelism, right? We had to come up with a way of running queries in parallel, and we had to come up with a way of not crashing when we run out of RAM and all these interesting things. Like, actually, that's the point I wanted to come back to, because in the very first sentence, you said DuckDB is an in-memory system, and that's only part of the story. So DuckDB is actually a larger than memory system. So there's this thing that traditionally database systems, they try to be very conservative on memory usage. Like if you run Postgres in the default configuration, it uses like 32 megabytes of RAM. It's ridiculous. Then there were in-memory systems like, I don't know, SAP HANA and a bunch of other systems that used only memory, and they would crash if they would run out of memory. That's not great either, right? And then so what we have is actually like a third-gen system, is where we use memory. You know, we'll use your memory, no problem, right? Like if it's there and it's free, we'll use it. But if things stop fitting in memory, we don't just crash. We actually have wonderful mechanisms to use as much memory as we can, and then gracefully degrade performance as we start using disks and these kind of things. So these are also some of the what should I say, some sort of orthogonal issues that you don't really think about, but they are extremely, critical to get right, like parallelism, like transactions, like storage, and we just spend an enormous amount of time. And I'm super grateful for our team here at DuckDB Labs that has people that are experts in all of these things, and they spend all their time working on that. So that's really cool to see. But it takes an enormous amount of time to get all that right. For example, also the storage format. I've mentioned our storage format, right? We have this DuckDB file that is just a file, a lesson we took from SQLite. You can email that file around. Okay, so now you have this file, and now DuckDB, you update DuckDB. Now what happens to the file? Like in the past, it meant that you had to reload the data because, new version, things change. But now, since the last version of DuckDB 0.10, we actually have backwards compatibility on the storage format, which is a whole other bucket of pain. Like, how do you define a storage format you still need to be able to read in 10 years? We promise that from every version from now on till infinity future, we'll be able to read the files that you create today. Well, that's, first of all, it's a big commitment for a software project, but it's also something from a technical perspective that's really tricky to get right. Like, forwards and backwards compatibility is tricky. So there you easily spend, many months on dealing with these aspects. So then it's not that surprising anymore that you take 6 years to get to 1.0.
Right. Yep. It makes perfect sense. So you're almost at 1.0 now. And by the way, DuckDB, I don't think we've talked about it yet, but it's open source. Is that correct? So you do have community contributions, and it's available for free for people who want to use it, et cetera, et cetera.
Yep.
All the normal open source things. But, many companies struggle with the monetization side of open source. What is your solution to that?
That's an excellent question. And I think we are all too sort of burned by the recent rug pulls that have happened in that space. So DuckDB is free and open source under the MIT license, so you can go ahead and do whatever you want with it, and there's no restrictions, which is, I think, really important to gain wide adoption. We do have, we have a GitHub, you can send us pull requests, that's perfectly fine. How do we monetize? So we actually don't monetize DuckDB itself. DuckDB itself is actually owned by a nonprofit foundation, the DuckDB Foundation, that has it in its statutes that it owns the name, the trademark, and all the IP in the implementation, right? So the project itself, it's just open. There's no money to be made there. Our company, DuckDB Labs, that employs most of the people that work on DuckDB, Mark, me, a bunch of other people, we finance ourselves not by VC money, which is what usually happens. So usually what happens is that you start a project and you get VC money until that runs out and you have to make the hard decisions. No, but we are actually self-funded. We're bootstrapped. So we had the big advantage that we were working at a research institute for the first 3 or 4 years of the project's existence, which meant that we didn't have to, pay our salaries. We got research grants from a bunch of organizations, so it was fine. But it meant that we could kind of get the project sort of close to being useful commercially. And so when we spun off the company, we already had customers lined up that were ready to sign up as customers to basically pay us to add features, pay us for support for DuckDB. And with that, we fund the further development of DuckDB. So DuckDB Labs today is doing well. We are very happy. Still haven't had any investors. So it's still, the company is just owned by basically the team.
I wonder if there's any other companies, major open source companies, that have self-funded a for-profit entity that focuses on just the support aspects and not other products of their own and things like that. That's a pretty amazing accomplishment.
Well, thank you. I didn't set out in life to become a businessman, but alas, it's really interesting to see. So company right now, and you will forgive me the advertisement, if you use DuckDB and you need help, call us. It's 0900 quack, quack, quack. No, it's not. But basically we sell consulting and support contracts. So, if you need commercial support for DuckDB, if you need your favorite feature be added, then you can do that. We have customers big and small. We work for, the biggest companies out there. We work for small companies. And that's working out really well. That basically funds the whole show. It funds all our team. And yeah, it's been super interesting to try to build this. But yeah, as I said, what really helped was that we were coming out of this research world, which meant we had like a couple of years where we could just work on it and not worry so much about like money and things like that. And yes, we got some research grant, as I mentioned, but we didn't have to deal like with getting desks and, getting an accountant and lawyers, all the fun stuff that comes with running a company. And so when we were ready to spin out from the institute, it was good enough to basically charge money for supporting it. And we're still very grateful for the customers that signed up, then in 2021. Still very grateful for the people that signed up in 21, and they're still around, lo and behold. So we're still working with them, and we're very grateful because it's really made a big difference, and it allowed us to not take investment and basically keep control of our sort of roadmap.
Makes sense. So we're unfortunately rapidly running out of time here, and I've got so many questions to ask, but why don't I end with one kind of open question, and that is, what that we haven't talked about is something that's important that's going on that you would like to make sure we talk about and make sure we bring up?
I think what we haven't talked about is maybe the extensions. I mean, you briefly mentioned it in the beginning, I think, that DuckDB is extensible. And I think that's a super interesting future direction for the project and for us. So now we're all working on, getting the 1.0 out of the door at some point in the future. But what happens after that is, I think we're going to spend a lot of time on basically building an ecosystem, right? Where you or anyone else really can basically use a DuckDB as a platform to build their own stuff, to build extensions on. And where DuckDB kind of becomes this fabric of efficient operators and efficient data representations and all that stuff that you can glue various extensions together. And it's all accessible from sort of a unified interface. Look, that's SQL. And in that sense, I think we are we are trying to go a bit where Python is, where Python itself is great, but the real value of Python comes from the ecosystem of contributed plugins. And we're working very hard to make it easier to kind of build and ship and manage your own DuckDB extensions in multiple languages. So for example, we're going to add support so you can write these extensions also in Rust and maybe Go and C++ and anything else, so that anyone can really extend it. And I think that's going to be the next big thing for DuckDB, is going to be this ecosystem around it. But that's we have at the company, we have sort of two time frames. One is like pre 1.0 and one is past 1.0, and they're very, very different from each other. It's really fun. But it's also just been a lot of fun working on this. Like, it's been a blur of 6 years or so. I mean, obviously starting with Mark, and now it's just absolute pleasure to working with everyone.
Well, that's great. It sounds like a great project. I always tell when something is really interesting when I went from, I don't even know what this thing is, to I got to try this out in my next project now. So I definitely will be doing that.
Please do.
I already see a couple of use cases of things I'm working on right now that this would be a perfect fit for. I think we talked about CSV import, but also some things on I forgot what the term is, the AI distance comparisons and things like that.
Oh yeah, we have
And some of
support
those-
for that now as well. We have a plugin for vector search, things like that.
Exactly, yes. Yeah, the vector
Yeah,
analysis.
an extension, see?
Yeah, exactly. Yeah. So I might use it for that as well. So anyway, very interested. I'm going to learn a lot more about it and start using it. And I appreciate your time. This has been great. My guest today has been Hannes Mühleisen, who's the CEO and co-founder of DuckDB. And did I get that pretty close on the name?
You got it right. Thank you.
Wonderful. DuckDB is a modern, extensible, open source, in-memory and out-of-memory analytics database engine. Hannes, thank you very much for joining me on Software Engineering Daily.
Thank you, Lee, for having me.